So we're going to look at some of these probability questions now from independent events and tree diagrams and stuff like that. 3/4 of all light bulbs in a country are made by glare, and 1/4 are made by bright eyes. So we have a G and a B here. 5% of glare lasts for a year or more, 5%, and 10% of bright eyes last for a year or more. Okay, so we've two things going on here. Let's just start this off. We have glare, make 3/4. So we can say that of that 3/4, glare, just double check, 5% lasts for more than a year. So of that 3/4, 5%, well, I can do 0.05 lasts for more than a year. So 95% don't. And actually, I'll just change them all to the same. We're dealing with decimals, 0.75. And bright eyes, who make 1/4 of them, 0.25, have a percentage that lasts more than a year and less than a year. So +1, or actually greater than 1, we go greater than 1. Greater than 1 are these two here, and less than 1 are these two here. So what percentage of glares, 5% lasts for more than a year. 10% of bright eyes, 10%, 0.10 and 0.90. And we're asked to draw a tree diagram, which we're doing, of the probabilities. If you want to buy a light bulb at random, what's the probability that it will last more than a year? Right, so you're putting your hand into the pot. You're finding out what the probability of this one is, lasting more than a year, and what the probability of this one is. So 0.75 by 0.05, that's how many will last more than a year for G, and for B it'll be 0.25, and this is giving you the total. This is 100% of the light bulbs in Ireland, and that's going to be multiplied by 0.10. So the answers to these two: 0.0375, and this one down here is 0.025. Just move the decimal one place, and adding them together, we're going to get 51.25, 0.0625. That's the answer to this one. Yeah, nothing else asked in that question. So 23. If a day is fine, the probability that Mary will be late for school is 0.4. And if the day is wet, the probability goes up to 0.5. In Ireland, 20% of all school days are wet. Find, using a tree diagram again, the probability that on a random day in school, Mary will be late. So she will be late. So let's have a look at just changing colour, and we'll look at this one. So we have to start looking for all days. That's what we start with. 1/4 and 3/4. And last 20% of all school days are wet, which means that 80% are not. So that gives me the starting point here. So I have 0.8 and 0.2. So that's not wet. And this is wet. And then we can build from here. So what else have we got? We have, if a day is fine, the probability that Mary will be late for school is 0.4. We can build from there. So the day is fine, it's not wet. So 0.4 is late. So she's at 0.6% of not being late. I'll just call it NL. And then if the day is wet, the probability goes up to 0.5. So she's a 0.5% chance of being late, and a 0.5% chance of not being late. And we're asked, find, using the tree diagram, the probability that she will be late for school. So will be late is this branch and this branch here. So 0.8 by 0.4 is 0.48 or 32, and you have two decimal places. and we have 0.2 by 0.5, and 2 5s are 10, and because we have 2 decimal places, 0.1010. So the overall chance is 0.42. That's question 23. Now 24. Again, the last one of these 3 diagrams, I think in this, we'll go on to the next video, I want the 3 diagrams. A bag contains 5 red sweets and 4 green. 5 red and 4 green. Pete takes 3 sweets out in succession and eats them. The probability that all 3 are red, and 1 is red and 2 are green. Actually, 24, we're not asked for a 3 diagram, so I'm just going to do it out. 5 red and 4 green. Right, so these are easy enough questions. So what's happening here? We have to, what's the probability all 3 are red? So you put your hand into the bag, the chances of getting a red are obviously 5 over there are 9 sweets. Now he's eaten that red, so there's 4 of them left. But there's only 8 in the bag. And then he ate that one, there's 3 of them left. And there's 7 in the bag. So 5 by 4 by 3 over 9 by 8 by 7 is going to give me 5 over 42, is that right? 5 over 42, I think. Not asked for it as a decimal, probability fraction's fine. And then 1 is red and 2 are green. So 1 is red and 2 are green. So we can have 1 red, red, green, and green. So the only thing that can happen here is that red can change place where it comes up in the order if there's only one of them. So that must be the possibilities then. Red, green, 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 red, green, or green, red, green, green, red. So we need to add these probabilities together, and actually you might see a pattern develop here with the numerators and denominators. So to get red first, it's going to be 5 over 9. To get green second, there's 4 green. So 4 over, there's 8 sweets left. And then there's 3 greens left, and there's 7. So that's that one. 5, 4, 3 on top, 9, 8, 7 on the bottom. What about this one here? Now, because there's 5 and 4, this is why this works out. Green, red, green. So the probability of green is 4 over 9. And then we're onto the probability of red next. Well, there's 5 of them left. And there's 8. 5 over 8. Now we're just swapping the numerators around here. And then the probability of green to finish, there's going to be 3 of them left over 7. So you're going to see here that the denominators and the numerators match, and they're actually the same as question 1. So the answer to this one is going to be 5 over 42 plus 5 over 42 plus 5 over 42, or 5 over 42 times 3, which is equal to 15 over 42. Well, let's just double check this one. Green, there's 4 greens, there's 9 in the box or the bag. Green left, there's 3 of them, there's 8 in the bag. And then red, there were still 5 red, and there's 7 left in the bag. So you can see again we have 3 by 4 by 5 on top. So all of these probabilities are the same in this case. So we can say the answer is 15 over 42, or that's going to be 5 over 14. So just get used to practicing these questions. The math involved is really simple. It's really the questions, how they're asked, can be the difficult part within probability.